The urgent and existential risks of the global climate catastrophe, according to Guterres, has dealt, quote, a major blow to the UN SDG implementation efforts. We examine the impact on biodiversity of a major natural disaster that received international attention, the 2019-2020 Australian bushfire season, or Black Summer event. Australia is the flattest, driest continent in the world, and Australian bushfires represent some of the most intense and catastrophic fire seasons on record. How we respond to natural disasters is considered an indicator for better or for worse for many around the world. High-quality, data-driven research supports policies and legislation for ecosystem and biodiversity preservation. We come from 5 countries. Our team of PhD students and early career researchers have real-world and applied research experience in data science, bioinformatics, data policy and governance, and indigenous perspectives.
Hi, I'm Dr. Sherry Jiang from Monash University, and I work on developing software to analyze multivariate spatial temporal data.
Hi, I'm Alex Quinn, a research assistant at the Sydney Precision Data Science Centre at the University of Sydney. My primary field of research is in bioinformatics, wrangling and extracting data-informed conclusions from high-dimensionality datasets in biology.
Mabuhay, I'm Ruben de los Reyes, and I'm a PhD student at the University of Melbourne doing health informatics research.
And John Lyons, a member of the team, is a PhD student at the Queensland University of Technology and member of the Australian Data Science Network, and he's researching regime shifts in Antarctica. And I'm Dr. Bernadette Highland Wood, an early career researcher working on the dynamics of government data supply and national governance practices. I teach digital communication at the Queensland University of Technology in Brisbane and am affiliated with the QUT Centre for Data Science. Collaborations by diverse teams with backgrounds in data science, natural and social sciences are key to achieving the Sustainable Development Goals. Our project aims to address SDG 15. We produced a quantitative analysis to support recommendations to achieve targets and indicators for SDG 15.5 specifically. Biodiversity is in crisis. Wild animals and plants are disappearing at rates never before experienced during human existence. And scientists predict that 1 million species are headed for extinction within the coming decades as a result of human activity. By taking urgent and significant action to reduce the degradation of natural habitats, we can halt the loss of biodiversity and protect and prevent the extinction of threatened species. This work will directly impact government decisions by generating an open data resource for ecological policymakers to reduce the burden of future natural disasters on wildlife. Biodiversity is the term researchers use to describe the full mix of life on Earth, from the tiniest insects to the tallest trees and everything in between, including humans and our impacts on the natural world. It refers not only to the number of plants, animals, and other organisms, but their variety, which is significant since each different species has an important part to play in the larger whole. Biodiversity indices are a proxy measure of overall species diversity in a given region, and it is an important measure for helping us to understand natural barriers against many diseases, including diseases that can turn into pandemics. For example, conservationists and environmentalists use biodiversity indices to assess the health trends of ecosystems and species, ultimately to develop strategies to protect and restore biodiversity. Government agencies use these models to inform policy decisions, land management, and conservation planning. Land planners and developers may use them to guide land use decisions and ensure projects are environmentally responsible. Sustainable agriculture and forestry experts use biodiversity models to limit negative impacts on ecosystems such as habitat destruction and species loss. They are used by educators, researchers, NGOs, and nonprofits for environmental advocacy efforts. And indigenous peoples often have a deep knowledge of their ecosystems and may use biodiversity models to complement traditional knowledge for their efforts to protect and manage country and waterways. Planners and policymakers are guided by disaster models for assessing immediate and long-term impacts of bushfires, helping to coordinate response efforts, and to allocate resources and plan for recovery and reconstruction in a data-driven manner. Our project focused on the 2019-2020 Australian bushfire season, or Black Summer event. And if you're not familiar with what happened, from September of 2019 to March 2020, bushfires heavily impacted various regions of Australia. And the most severe fires peaked from December of 2019 to January of 2020. A massive fire, characterized by its unusual intensity, size, duration, and uncontrollable dimension, are now considered megafires. What we did using open methods and open data is to examine how to better monitor and evaluate the impacts of natural disasters on our terrestrial ecosystems and biodiversity. We performed exploratory data analysis using data from the Digital Atlas of Australia and the Atlas of Living Australia. We looked at multiple fauna species and used Clark and Warwick's Taxonomic Distinction Index for biological community data. And this index defines two biodiversity indices, capturing the structure not only of the distribution of species, but also the taxonomic relatedness of each sample, giving us a richer image of the ecological landscape in a region. For each bioregion, our team leveraged open data and R, one of the most widely used open source programming languages for statistical data analysis. Using existing disaster indices, we performed a biodiversity analysis and produced visual plots using Python, R, and Mapbox. Our data pipeline package, called Disaster and Diversity, calculates the ecological impact of natural disasters using biodiversity indices and the monetary costs for disasters. Our package can be used in combination with other metrics to monitor, measure, and evaluate the impact of natural disasters. Our deliverable is an R package, and it includes a collection of functions to perform tasks, including to locate area from natural disaster open data, extract the respective shapefiles, query species from the Atlas of Living Australia, compute biodiversity indices, and create visual plots using geospatial multivariate data. Our functions can be called and used in other R scripts. Our packages include all the data sets that we used, and we've included documentation with information on how to use the functions and the data sets. A core objective of open source software is, of course, reuse, so we associated the MIT Open License with our R package. And in doing so, we've achieved the objective of leveraging the work of others who came before us in the fields of biodiversity and data management. So through this project, we performed applied research on ecosystem resilience. Accurate and up-to-date open data and multi-stakeholder collaboration are essential. With the increasing frequency and scale of natural disasters, understanding, monitoring, and evaluating these transnational events requires access to open data, open source platforms, and collaboration with multidisciplinary teams. Open data is often made available as a public good. The Atlas of Living Australia's open data was central to our project. This Open Data Atlas is an excellent example of collaborative digital open app infrastructure, and it pulls together Australian biodiversity data from multiple sources and makes it accessible and reusable. The Atlas of Living Australia is the Australian node of the Biodiversity Information Facility, an international network and data infrastructure. And it's a network funded by the world's governments and is aimed at providing anyone, anywhere, open access to data about all types of life on Earth. The ALA uses the Darwin Core set of standards to mobilize and deliver biodiversity data. Darwin Core is the internationally agreed standard to facilitate the sharing of information about biological diversity, and it conforms to the Fair Data Exchange principles. So in conclusion, our 5-member Australian-based team of ECRs hailing from 4 countries produced tangible deliverables during the 3-day datathon. During the 2023 Datathon, we addressed SDG 15.5 by looking at biodiversity loss in the aftermath of natural disasters. We showed that a multidisciplinary collaboration is essential to conservation and sustainable ecosystems and biodiversity in Australia and beyond. Our team conducted analysis to calculate biodiversity indices that support monitoring and evaluation of bioregions and disaster impacts. Australians, like many of our South Pacific neighbors, want to see their nation rebuilt in a way that treasures and protects our unique wildlife. By monitoring, measuring, and evaluating biodiversity and natural habitats, we can reduce losses, ensure conservation, and protect valuable genetic resources and more fairly share the benefits of our terrestrial and ocean ecosystems. Collaborative, multidisciplinary, data-driven projects are only possible through the passion, commitment, and financial backing of multilateral organizations such as the United Nations and event sponsors and National Australian Data Science Network. Thank you. Together, we're working to support economic, social, and environmental benefits for present and future generations.